Hello and welcome to Cloud Tech Talks. This is Pritesh. I'm back with another video. In this video, I'm going to talk about infrastructure as code and what it means. And I'm going to link it to the previous video I did about evolution of technology so that you can relate how it's flowing into the subject really well. So let's get started with this very quickly. So for your reference, I've kept the previous drawing from the previous video where essentially we spoke about the evolution of technology, and really quickly we spoke about hardware to virtual machines to containers to serverless. We also discussed the difference between virtual machines and containers. Now, where does this concept of infrastructure as code come into play? It comes into play when we talk about scale, and scale is essentially what makes life difficult for the people who manage this kind of infrastructure, right? So let's think of it in a standard environment. Let's pick this container environment here and think of it as being deployed for a business which is growing really fast. The user base is growing, and the amount of users at every given hour is also growing, and consumers are demanding more and more features and updates to the applications every day. Think of it as banking applications or e-commerce applications where people are coming and shopping or executing transactions at every given point in time, and you can't afford any downtime. You can't afford not to provide that feature at scale, and you really have to be ahead of the competition, and speed is of the essence, right? So that's where the term infrastructure as code comes into play. Now, also known as IaC, right? What it essentially means is that any organization who wants to implement this policy or practice needs to think of their infrastructure as a specific code in their company, right? And a code has a specific function to execute, and it does it in an automated fashion. Just like any other code for any other application, your infrastructure also has to run by a specific code. And if you implement this logic, then you are able to implement a lot of things for your business. Like number one, you can definitely achieve speed, right? So you can since you adopt this approach, you can do much more with your given time as opposed to what you used to do earlier. You can automate. I'll talk about this on how this automation approach works. You can also define workflows, right? So essentially, if there are specific approval workflows to this infrastructure provisioning, where someone at a business layer has to approve a specific provisioning of a specific environment on a container or even on a virtual machine level, how can that be seamlessly done via a workflow and without any human intervention, right? Most importantly, it has to bring in the agility that is required for the business, and it has to bring in scale. So essentially, we've more or less touched on what are the key benefits and what kind of things people can achieve if people adopt this approach. Now let's take a practical example. We are talking about a website here. Let's say www.abc.com, and in this case, the user count today is, let's say, sub 10,000. Close to 10,000 users hit this website every day. They do their transactions on a regular basis. They execute it online. They avail the features. They log into portals. They do everything that's required. And this essentially is running some kind of a container environment in the background on a public cloud or a private cloud, right? It could be combination of both, right? Now, if you go by the logic of this scale, 10,000 users, this could very well become 20 to 50 to 100,000. Now, the same kind of infrastructure after a given point cannot really serve the purpose. Why do I say so? Is because most of these applications, they are going to have some form of bugs or fixes or updates or patches which need to be deployed on a regular basis in order for these users to have a seamless experience. What do I mean by that? Let's say today they are running this website, and on the right hand side they have a let's say login button, using which people log into the portal and they execute a specific transaction. Let's say they wire money from country A to country B, right? If you're doing this transaction with 10,000 users in the background doing it simultaneously, the whole process is dependent on how well these apps function on this infrastructure, right? And along the way, there are going to be new updates or new regulations or new things that are going to be required by consumers, or from a compliance perspective by the company themselves, in order to change something about that app, right? So you can't really keep firing up a container all the time and depend on a human being to do that for you, because all of this transaction is happening real time. How can you depend on one single or an army of IT managers sitting and managing this environment in all practicality to serve this requirement for users? And bear in mind, this is going to scale with time. It's going to be 10,000 more, going to be 100,000 more, going to be 50,000 more. It could be anything, right? IaC, what it does is it essentially automates a lot of things about how you provision the infrastructure itself, right? So let's say you use some of the modern day tools. Let's talk about Terraform. Terraform is a infrastructure as code tool which is provided by a company called HashiCorp, and what it does essentially is it allows any IT manager or managers to automate provisioning of this kind of infrastructure, right? So what it will do simply is give you a code which you will have to write one time in the beginning, and you base your business logic, base your infrastructure logic on that code. What kind of rules you need for compliance, what kind of rules you need for users, and scale, and the ability to automate and deprovision or provision anything that you need, right? So let's assume that this 10,000 users are demanding potentially 100 containers today. When you move from 10,000 to 100,000, maybe they are going to demand 500 containers, right? Now when you're deploying 500 containers, all of this business logic can be written in this code itself, which the tool utilizes. So this code essentially helps you scale from 100 to 500. That's the first advantage. Secondly, it also identifies something lying idle in your infrastructure. So it may so happen that when you scaled from 10,000 to 100,000 users, and you scaled back from 100,000, let's say, to 50,000, because it was a seasonal requirement, and after that all of the users, they left and they are not transacting on your portal anymore. But for some reason your infrastructure still has 500 containers, which means you're still paying for 500 containers at your provider level, at your infrastructure level, which is essentially money to the business. Every second counts, right? So this infrastructure as code approach, the tools you use, can actually identify that idle resources and bring that provisioning down as well when the time comes. So these are some of the basic terminologies that I wanted to touch on as far as infrastructure as code is concerned, but they are all aligned with these benefits which we discussed earlier. How do you achieve speed? How do you achieve agility? How do you achieve infrastructure at scale with automation without any dependencies on human beings? And how do you continue to innovate as far as your business processes are concerned? Because remember, there is an old saying in IT, if you have to do it twice, you should automate it, right? So that's the whole concept of infrastructure as code, and why it's so important for IT managers in this modern day and age to adopt to this approach. So this was a very brief explanation of infrastructure as code as a concept. Hope you liked it. Please provide your feedback in the comment section below. Until next time, this is Pritesh signing off from Cloud Tech Talks. Thank you.